Hello, hello.
Howdy.
Hello, Jesse. How are you doing?
Good. How about you?
I'm doing good. I'm doing good. Recovering from a little virus.
I thought you were
My
going to say recovering from testnet launch.
Oh yeah, there's that also. Shortly after we launched test. By the way, did I mention we launched testnet? Shortly after launching testnet last week, we got a virus, and so that's the reason why.
So your physical human body, not the network.
Yes, my physical human body is the strongest attack vector. Um, Correct. Yeah, and that's the reason why our announcement pipeline got a little hiccup. Why we didn't solve all the hiccups as rapidly as we otherwise would have. So right now the status is you can participate in BetaNet, but it requires you to download the source code and compile it locally. And if you can do that, you can totally participate. If you can't, then we have a problem because our production of binaries and installers doesn't work yet, and so this is a bit of a develop DevOps task that the right brains didn't sit in the right in the same location at the right time yet, and we're certainly going to fix that at some point soon. But since we didn't fix it, we'd like to make an announcement to the broader.
Oops.
Sorry, we'd like to make an announcement to the broader public over multiple channels with links to installers and binaries.
Right. So that means that you can install the software now to run a Neptune node. You just need to compile it yourselves, which is pretty technical step. And the sort of the .exe and .dmg for Mac, those executables are coming. They're just not ready yet. And as soon as they are, you're going to make a bigger announcement.
Correct.
Cool.
And
Well,
so this podcast happens to be recorded in the time uh, between having launched BetaNet 1 week prior and before the arrival of the installers and binaries.
okay, exciting times. So
Exciting times.
congrats on that.
Thank you. Thank you.
How has it? Have you monitored the network traffic? Like, what's been the reaction from people or from the network?
So we did announce the launch of the network in one place, which is on the Telegram channel, and we got a lot of congratulations from people who knew that from prior personal anticipations that something was coming. And a whole bunch of people joined the network. I think we have five different participants, some of whom are probably running multiple nodes. We can tell because they are behind the same NAT, and so their IP addresses are the same. And it's exposing interesting things like they're not being discovered as the same IP. And we probably want to still allow that because plenty of people are running nodes behind NATs, and so you can't just ban IPs because then you're banning potentially legit users. On the other hand, it does mean that if you have one IP, you can pretend to be 1,000 different users, and that's a bit of an attack vector there. That yeah, there are countermeasures against, but it's
Sorry,
worthwhile knowing.
what abbreviation are you using? A NAT. What did you say?
Network address translation. So the thing is that there aren't enough IPv4 addresses for everybody. And so what your what your ISP is probably doing is it has one IP or a small number of IPs for a larger number of clients. And then from the point of view of the rest of the internet, it's just one IP, but many different ports. And it uses the port information to know which packet is destined for which client.
Okay, gotcha.
Yeah, and we had some issues also with the two bootstrap nodes. So in the README file, we provide two IPs of nodes that Torquil and I run. And we initially launched them with max number of peers set to 10. And lo and behold, that maximum was reached far sooner than we had expected. And at that point, people couldn't connect to the network anymore because the max was reached. And so that's how you discover that you're missing something that's demanded by the world. And so we fixed that. Now the bootstrapper nodes disconnect from the oldest connection whenever there's a new incoming connection. So you will always be able to get a entry point into the network. You use the bootstrapper nodes to discover other peers, and then you're a part of the network. And things.
And so are you a bootstrapper node, or who?
I'm running a bootstrapper node, and Torquil is running the other bootstrapper node.
Okay, gotcha. So that's like the first connection that you make, and then through there you discover other nodes, and then you're plugged in.
And by the way, anyone who wants to run a bootstrapper node can run a bootstrapper node. The code is open source.
And so the people that are now running nodes, or that have tried it out, what's the like? Are those just enthusiasts? Like, what do you think is going on there?
Probably some enthusiasts. I think most of them are eager to start mining. And they were eagerly anticipating BetaNet because if you can mine on BetaNet, then you will be able to mine on mainnet as well. And it's not obvious that you would be able to mine because mining can be prohibitively expensive because mining consists of two steps, composing and guessing. Composing is where you assemble transactions, merge those transactions, and that's the expensive step, and then produce a block out of that merged transaction. Merging transactions is expensive because you take the existing proofs and you replace them with a proof that you verified the original proofs. And there's no way to do that composition step on a computer half the size. Either your computer is large enough or it doesn't work.
Okay, wow. And how long are we talking? How long does that take on your system, for instance?
On my desktop computer, which has 62 gigabytes of RAM, I actually still need 5 gigabytes of swap on top of that, and then it takes around 20 minutes. But we have a beefier machine with more cores, more RAM, and it takes around 5 minutes on there.
Okay, cool. And the miners, they've got the best hardware, so they're probably in a good position.
Well, maybe they do, maybe they don't.
Of course.
It's certainly in the early days of Bitcoin, there were no ASICs, there weren't even FPGAs, there weren't even GPU miners. You were just mining on your CPU. And the numbers that I just gave you, by the way, 20 minutes on my desktop and 5 minutes on a beefier machine, those are for CPU miners. But if you want to switch to excuse me, if you want to switch to GPUs, then those numbers are probably going to drop. But we don't know yet by how much because we haven't written the code yet. And we haven't written the code yet because we're busy focusing on other things.
You haven't written the code yet for mining, or for what?
Proving specifically on GPUs.
Ah, okay. And the can people mine right now?
They can. Um, Hang on, there's a dangling piece of train of thought that I left in there. So mining consists of two steps. One
Right.
is composing. That's where you assemble the block by merging transactions from your mempool, and the merging is the step that involves proving. And the second step of mining is guessing. That's where you guess the nonce in the header to make sure that the block's hash is smaller than the target. And guessing works on any CPU, no matter how small.
And so remind us what's the point of both steps, or like of adding the guessing part?
Well, the guessing part is a Poisson process, which means that you do not have a state that you do not get incrementally closer to your goal the more time passes. With every guess, you're starting from scratch again. And this is useful for the purpose of generating consensus because once you have a successful guess, everybody can verify that it was successful and nobody is halfway there, which means that they don't have an incentive to ignore your block. It's a quantum step. So the guessing part is essential for producing consensus. The proving part is essential for making the system scalable.
Gotcha. Okay, cool. So exciting stuff. The network's got some initial adoption. Do you have any ideas how many nodes are on there now, or is that not visible?
Right now, my Bootstrapper node is kind of incorrectly named because I've written the software already, but it's not using that software yet. So it's still maxed out at 10 peers. But I don't know how many peers it would have connected to
Oh, okay.
if I had updated the software.
Okay, gotcha. So it's still early days, we could say.
It's still early days.
Okay, cool. Well, the congrats again. And so where does that leave the Neptune team? What's sort of the next steps now?
Well, the next step is mainnet launch. The thing with BetaNet is that it's not quite on par in terms of features with mainnet, but it's pretty close. Um, we are missing things like time locking, the rewards of the composer. So one of the ideas that we had while we were designing Neptune is that the miner's reward should be split into a portion that's liquid from day one and a portion that's locked for a certain number of years. And we didn't get around to implementing that yet. Um, uh, there are similarly small things waiting, but this is a matter of weeks to be done. We need to embed into the Genesis blocks all the allocations of pre-mine coins to investors. And in terms of programming, this is a trivial task, but there's a lot of administration that goes into making sure that we're getting the numbers right and making sure that we have the public keys from all the investors and so on.
Yeah.
And then there is
You can add a zero to mine at the
I
end.
can add a zero to you. Okay, I'll bear that in mind. On the left side, you mean, right? All right. The last big task that's remaining is the security review. So yeah, if something is wrong security wise, it could lead to undetectable inflation, and then we have a lot of egg on our face and would need to restart the network, and so we really want to avoid that.
And how are you going about that?
Tediously, step by step, we have a graph of all the functions that were called, and then we're just going to turn every assert code into assert with assert identifier, so that we can trigger the assert. So the assert code is supposed to panic when something is wrong. It's all the asserts together are what make the system sound, and we want to be sure that we can trigger every assert individually. And in the process of writing tests to trigger those asserts, we hope to find all the possible ways in which these things could be exploited.
Okay, cool. So it sounds like you are quite close then to mainnet in terms
We
of.
are close. We are close, but it's still too early to put a date to
Okay.
when we will launch.
Okay, fair enough. And so, any remind our listeners and viewers sort of what the feature set is now in testnet, and if there's any major things that people might expect that are not there yet and are for later.
So transactions are proved. Whenever a transaction circulates, it circulates with either a single proof or a collection of proofs. And those collections are turned into single proofs, and two transactions supported by single proofs can be merged into one transaction, again supported by single proofs. And so this aspect of scalability, where you don't pay for witness data, is already in place. So if 1,000 transactions come in, then you have a block with 1,000 transaction kernels, or it will still be one transaction kernel, but the space occupied by the kernel is just 1,000 times the space occupied by one kernel, and there will be one proof. And so that's an aspect of scalability, because on the margin, the cost of adding an extra transaction is as small as just the kernel and not the witness data. That said, it does require someone to produce those proofs. And unfortunately, at this time, producing those proofs is still rather expensive. And so in the first few weeks, maybe even months, we're not going to see blocks with the merger of 1,000 different transactions, because it takes a while to produce that. I mean, yes, you could split it up into 500 different tasks in the first layer, and then 250 in the second layer, and so on. And so you would only have to wait 10 times 5 minutes. 50 minutes is already a very long time to wait. But even if you were to do this parallelization, you would end up paying a lot just to rent those machines. So the technology is there, the code is there for supporting scalability. What is it? The verification code is there. The blockchain logic is there, but the GPU code that's going to make it fast and scalable is not there yet. What else is there and versus not there? The mutator set is there, and so all transactions preserve privacy in the way that you would expect them. By the way, there was this minor drawback in relation to standard address format, whereby if you broadcast your address, say this podcast has a donation address, people sending money to that donation address, they can do so anonymously, but different donations to the same address will always be able to be linked as different donations to the same address. That was an intentional trade-off, but
We
there's a
talked
way to get
about, we
around
had
it.
an episode about this.
We made an episode about that. We have a way to get around this if you don't broadcast, if you don't need to broadcast a address. So if it's just two people who already share a secure channel, they can transfer all the necessary information off chain and put only the essential information on chain, and the essential information is not traceable at all. So that's in place. We have an explorer. Explorer.neptune.cache is in sync with testnet. These things are all in place. And then in terms of what's lacking before mainnet, it's small pieces of logic that make the picture of mining complete.
What about a wallet?
What do you mean by wallet?
Well, I guess nowadays something that maybe someone can use on their phone and that they can receive and send Neptune transactions.
Right. We don't have any smartphone or iPhone apps. No.
And anything like an executable for computers.
Well, you mean besides the client? Right, because what we've built is software. How did you expect to run software if not through some executable of some sort?
It might be that my mental model here is lacking, but I'm not interested in running a node, not interested in mining, but I just want to, let's say someone's given me Neptune and I want to send it to someone else.
Right. Yeah. So we do have a user interface. We have two interfaces to the user actually, but one is graphical. One is more graphical than the other. They're both terminal based. Well, in fact, one is command line based and the other is terminal based.
Command line or terminal?
I don't see the apparent contradiction.
Well, to me, they both sound like black screens with text-based input.
They are both screens. The dashboard, the dashboard reacts to your arrow symbols and it highlights text where you're currently focused, and you can switch tabs.
So
it still only works from your terminal.
Okay.
Whereas the command line interface, you literally type command send 10 coins to Jesse. Actually, send 01 coins to Jesse.
Yeah. So it's hardcore still.
It's hardcore. Yes.
Yeah.
Yes.
Which makes sense. Okay.
We don't plan to produce a smartphone app in the near future.
Yeah. No, I figured. Just to be clear. Okay. Cool. Makes sense.
Then the next stage of evolution is what happens after mainnet, and it's worth drawing attention to the fact that we don't have succinctness yet, and we certainly intend to build that in and deploy it through a soft fork. We also have improvements to Triton VM in the pipeline so that you will be able to produce proofs faster. And unfortunately, that's going to require a hard fork, but we're prepared to bite that bullet.
Okay, cool. So
Awesome. Excellent. Sure thing. Take care. Bye-bye.